Very pleased to see you here this evening. It's a pleasure to introduce our speaker, Professor Peyton Young. Professor Young is an eminent scholar with specialities in game theory and finance. A mathematician by training, he's used his expertise in probability and dynamical systems to study the evolution of social norms, the learning of equilibrium behavior, and the stability of financial systems. Among his affiliations, he's a professorial fellow at Nuffield College, Oxford, research professor at Johns Hopkins University, a non-resident senior fellow at the Brookings Institution, and he's a former president of the Game Theory Society, a fellow of the Econometrics Society, a fellow with the British Academy, and he's also, I'm very delighted to say, LSE Centennial Professor in the Department of Mathematics for the next 3 years. For those Twitter users in the audience, the hashtag is #LSE Peyton Young. This evening event is being recorded and will be subject to technicalities permitting, posted subsequently on our website, along with the slides themselves. So I'd like to thank Rebecca Lum of the Mathematics Department for basically single-handedly organising this evening's event. Thank you, Rebecca. And Peyton will speak for about 50 minutes to an hour, and then there'll be time for many questions afterwards. So will you please join me in welcoming Peyton Young to deliver his lecture entitled The Diffusion of Social and Technological Innovations.
Martin, thank you very much. Pleasure to be here, and thanks very much also to Rebecca Lum and to Kate Barker, who helped put this final significantly improved touches on this lecture. I feel a little bit awkward in giving a mathematics lecture at the same time as a public lecture. So I've tried to pitch this in a way that would appeal to people both in economics, sociology, anthropology, various social sciences, and also mathematics without wading too deep into the mathematics. But you'll see that we're actually going to solve a differential equation about halfway through the talk. So it's not completely devoid of mathematics either. The topic is a very general one, and I won't spend too much time looking at the pictures here. I'll give you a taste of what's to come. I'm actually going to cover pretty much everything that's on this slide, but don't look too hard. Why is the diffusion of innovation such an important topic? We take for granted the benefits from innovation diffusion and rarely look at the process by which those things became accepted in society at large. We have, in developed societies, massively productive agricultural sectors that feed the planet. We have all kinds of medical innovations. We have more recently social and internet, cell phones, all kinds of electronic communications, which of course had to be invented, and in fact they had to be diffused in society for that to have an important effect. Now, I say we take this for granted in developed economies. Where this is not taken for granted, and development economists have been in the forefront here, is in developing countries where actually very simple ideas often take a long time to be established, ideas which could benefit the society, would lead to it being more productive, but for one reason or another, even though everybody's been told about the benefits, they aren't taken up as readily as one might like. So why is that? That's the puzzle that I'm going to pose in this lecture. I also want to highlight something in the lecture that a dichotomy, if you wish, between the social and the technological. When we think of innovations, we often think of gadgets, technologies, and that's certainly heavily studied. But an equally interesting area are social innovations. The limited liability company is a social innovation. It's a legal concept. It had to be invented and then diffused and be widely used to be viable. various forms of accounting, insurance, compensation, and more recently, microfinance is an example of this in developing countries. I'm going to touch on this toward the very end. Here are two examples, and there are quite a few others, where the innovation is to stop doing something. Society finds itself locked into some kind of what is often called in the literature a dysfunctional social norm. And the problem is how to get society out by getting people to stop doing something when doing that something is part of an equilibrium. And an equilibrium is a very strong thing. It's held in place precisely because of the incentives that are created by the equilibrium. How do you, nevertheless, they can have very bad effects. So these are, if you wish, low-level or dysfunctional equilibria. So a very interesting application of these ideas is to the undoing or unwinding of certain social norms that are strongly entrenched, but one might think are doing harm. How do we approach that problem? I'm going to briefly discuss a couple of cases toward the end that are like that. So, as I've mentioned, it's not enough to discover something. It's not even enough that the discovery be widely known. What has to happen next is that the idea, the new way of doing things, gains acceptance. And this is the tricky part. Empirical work shows the diffusion process is very complex and can take a surprisingly long time, though in some cases it actually is fast. And actually it's the sociologists. I don't know if there are sociologists here, but I will give them credit. They have been in the forefront of this subject for many years. And exactly why that is true and why economists haven't been the ones leading the parade, I'm not entirely sure. I am going to mention some famous papers in economics on innovation diffusion, but it's quite clear to me that the sociologists pretty much got there first. And it's actually, I think, the interaction between sociological and economic aspects that is the most interesting way to think about the problem of diffusion. Let's split the problem of diffusion into two parts. First, let's look at the things that retard, that hold it back, and then let's look at those other things that propel it forward. So first, well, simply inertia. People hear about new ideas. That doesn't mean they immediately act on them. There's laziness, I'll do it tomorrow kind of thinking. And this is quite important. Empirically, one can see this in the data. Depending a little bit on the nature of the technology, there is simply conservatism. One is running up against a group of people. This is often more a problem in certain cultures than others, that people are just not predisposed to want to take on new ideas. And I'll give you some examples of that, including in the United States, by the way. Another feature is that the benefits are not at all clear. So ex post, we get confused about this, because ex post we say, well, why didn't everybody see that? I mean, we know that that was a good idea. We can see it. We can see how productive it was. But the trouble is that was not obvious ex ante when the idea was just getting started. And so this is especially true, and I'll mention key examples in a moment, where the link between the innovation and the benefit is not at all clear. Sometimes there's a lack of a good theory as to why there's a benefit. Merely there's an assertion that there's a benefit. It's not clear what the mechanism is. And then finally, and importantly, especially in the developing world, norm violation. New ideas run up against established practices, often religious practices, taboos, and prejudices, which prevent the idea from being accepted, maybe even actively prevent the idea from being accepted. That is, there are enemies of the new idea who will try to stamp it out. So those are the negative features. What about the positive ones? I'm going to break these into 3 or 4 categories. One thing that happens that can be very desirable when an innovation gets started is what's called an increasing returns phenomenon. The more that people do it, the more valuable the innovation becomes for everybody else. Actually, a very good example of this is various forms of communication technology. Communication involves other people adopting the innovation, otherwise it's not that useful to me. And so, you know, one telephone in the world is no good. 2 telephones, much better. 100 million telephones, much, much better. Now, here is a modern example. I wonder how many can guess what this is. You are going to be able to guess for sure if I tell you that on this axis we're talking hundreds of millions of people going from 2004 to the present. Facebook users. So actually this has gone off the charts now, and it's somewhere around 2 or 3 billion now. So that's an example of very rapid takeoff, and it's a brilliant example of increasing returns. The more people who are on Facebook, the more Facebook is useful to me. Second area of, that propels innovation is, it's obvious once we say it. Many innovations start off not very good. They're expensive, they've been poorly tested, they need to be refined, developed, improved, and as that process happens, then people adopt. Yes, and just there are many examples of this, but here's one where I'll not make you guess. These are mobile phone users in Finland going back to the early 70s, where there was a non-zero number of people using these things. They were about this big. You could put them in your car, but for sure not in your pocket, and they cost several $1,000s. Okay? Fast forward to this area here, the price has dropped by a factor of 20 or 50, and they're slim, they're elegant, they're stylish, and they work really well. Okay? And so one could argue, well, the innovation curve here simply reflects the decreasing cost, increasing benefit that has occurred over time. So that's true of some innovations, but not others. That is, that's one thing that can propel, but it isn't the only feature. The one I'm going to focus on here is what I'll call learning. As more people adopt, information accumulates that the innovation is actually beneficial. Now you might say, well, how many examples are there of that? Well, I claim that actually most examples are like that. Here are some illustrations of why the learning aspect is important. In developing countries where you don't have public, treated water facilities, you want people to boil water before they drink it so that it prevents disease. Now, the trouble is that while that's well established medically, the actual link between the boiled water today and getting disease possibly tomorrow is not clear to the people who are doing it. Another example, which we take for granted but wasn't clear to the farmers at the time, hybrid corn, a new idea, came along in the 1920s, actually quite earlier than that, but I'll get to that in a minute. It produced quite a lot higher yields, in fact, but it wasn't clear to farmers at the time that it really did. And here is more of a current example, which I'm also going to talk about, stock options. Are they good? Is paying executives in stock options a good idea for a firm to do? There's actually some conflicting literature on this. I'm going to address it with a recent paper that I wrote with a student. It's a current example where one would be entitled to some skepticism. Does it work? Does it enhance corporate value or not? I actually think one can debate this question even today. All right. So I'm going to draw out these points in 3 case studies. First, go into my favorite of all, the diffusion of hybrid corn. It's one of the great studies that launched the whole field of innovation diffusion. Then stock options, we'll turn to that. And then finally, I'm going to talk more briefly about the diffusion of contraceptive practices as an example where you have features that are both social and technological working together. So that's a complicated example of great interest to demographers. Okay, so here's where the caucuses were held recently in the US presidential choices. This is Iowa. And people in Iowa were at caucuses choosing various candidates. So This is probably hybrid corn. If they weren't growing hybrid corn, they're fools. Here is a, by the way, let me stop and say, along the way, I'm going to, in relatively small type, put the references to various key works. At the end of the talk, I give a full list, and that's online, or will be online, I guess. And so if you're having trouble reading that, it'll be available when you look online at these lectures. This is, in my opinion, the most important paper in the diffusion of innovation literature, period, full stop. It appeared in the Journal of Rural Sociology. In sociology, it's extremely famous. Here's what Ryan and Gross found. They studied 2 Iowa communities, and they did an in-depth survey of farmers in the early 20s and through to the 30s, 40s, and so forth. When did you start planting hybrid corn? How did you first hear about hybrid corn? What do you think the advantages of hybrid corn are? Do you think there are disadvantages to hybrid corn? Did you talk to your neighbors about hybrid corn? When you talked to your neighbors, did they have examples? Had they done it themselves, or were they simply telling you about things they had heard? They had this amazingly detailed survey about sources of information and what farmers said, at least, they acted on. But leaving that aside for the moment, here is the curve itself aggregated from the 2 Iowa communities. Now, this is a absolutely classic S-shaped curve, but as I'm going to show you in a minute, it actually isn't the one you're thinking of. It's not a logistic curve. One of the funny things about this curve is this business here. It's very slow to get started. It's slow and erratic. Logistics tend to sort of move up faster, and then they're a little bit more gentle in the middle, and then they tail off at the top. You can actually look at this data, and using statistical tests, you can reject that this comes from a logistic model. So something funny is going on here, and actually looking at this curve got me started thinking about this project. How do you explain this funny-looking data? Well, at any rate, so before we get to that, this is the most famous paper in economics on innovation diffusion. It's about the same topic, hybrid corn. Zvi Grilikus probably would have won the Nobel Prize for this, and unfortunately he died several years ago. What he did was he studied various states, not just Iowa, and he looked at their underlying soil conditions, and he said, well, I mean, there are lots of differences at the rate of uptake, at the rate at which things began. How do we explain that? See the huge differences between Texas and Iowa, let's say. Well, he said, let's apply a logistic model to this. We'll fit those curves roughly to a logistic. And in case you're wondering, this is what a logistic equation looks like. I've actually simplified it a little bit here so that 1 will be the upper bound of the diffusion, that is full penetration of the innovation to everybody, and P is the proportion between 0 and 1. This is the time path differential equation, and it has this solution for some constant. One thing that you should notice is that you better start with a P at 0 that's positive, because otherwise this isn't going to go anywhere. I mean, P dot is the rate of change. This says the rate of change is proportional to how many you have. So if you don't have any to begin with, you're never going to get off the ground. This is just sort of a quick fix that's done with logistic models. You just assume that there's something to get it started. When you do that, you find that regions with higher productivity inherently, meaning better soils, that explains the Iowa versus Texas differences. That is to say, the earlier adopters were states that had very productive soils, and they started earlier, and the rate of diffusion was faster. Okay? So this thesis was brilliant and clear and very economic. The rate of adoptions motivated by potential gains in profitability. And that's really remained a central paper in economics to this day as a way of thinking about the problem. Now, immediately, however, sociologists said, no, wait a minute here. Not so fast. While profitability is important, said they, many other factors come into play. norms and customs. We've already talked about that a bit. Just the general receptivity to new ideas. Of course, there are information campaigns, advertising that matter here. And then finally, the one I'm going to harp on, and that the sociologists also have harped on, is learning from others. Okay? So that's the Grillicus story, in my opinion, is fine up to a point, but it leaves out a number of key complicating factors, and those factors I'm going to try to persuade you lead to really interesting models, maybe even mathematical models. So since this is a talk in mathematics, I'm going to, without trying to bore you with the solution of differential equations, I'll give you a hint at why this learning from others is a tricky topic and leads to in some unexpected directions. So Ryan and Gross, in particular, found in their survey data that learning from others was the most important thing that farmers said mattered to them in deciding to adopt. It was not the local seed company representative come knocking at the door. It was not the local agricultural agent who was promoting hybrid corn. Farmers would listen to this and with a considerable amount of skepticism would say, well, maybe, and then ask their neighbors, have you been doing this? All right. Here then, and this will be the only slightly serious math in the talk, so we will get through this quickly. Here's a quick model of how you might approach this using a certain amount of formalism. So we'll start with the idea that agents have beliefs, prior beliefs about the benefits. That's a standard assumption in economics. They're going to observe outcomes, and they will update their beliefs. Very good. And when will they adopt? Well, let's say that they'll adopt when the expected payoff gain, given their posterior beliefs, exceeds their cost. Okay, so they'll wait for a threshold to be crossed, and then they'll be in a position where they want to adopt. That's the model. Very simple, but here's the funny math it leads to. Where is this information coming from? Well, it's coming from the cumulative experience of prior adopters. Now, in a standard old-fashioned logistic model, the idea was that the information was just coming through a kind of a contact process. I've done it, and I'm going to tell you about it in the local store, and that's the end of it. Okay? But here we're going to adopt a more, I should think, nuanced view of where the information is coming from. It's actually coming from this integral. Now, why is that? Because when somebody adopts, I get to see an outcome, say, for the first year. Now, if they continue to be an adopter for the second year, then I have to multiply that by 2. In other words, as the number of adopters going back in time, I look at how long they adopted, because all of this is producing more and more information. Well, that's what this integral is actually doing. We're integrating under the path of adoption for the population, and I claim that this is what needs to be studied when you look at this learning model. And then the dynamics get expressed by this rather fancy differential/integral equation. And you shouldn't think that you're able to solve this, because you're not. In particular, we don't know what the cumulative distribution F is that's leading to this. This is just some unknown cumulative distribution of resistance levels in the population, say due to conservatism by individuals, say due to pessimistic beliefs. And that's just some heterogeneity in the population that's there, very difficult to measure. So how in the world are we going to get a handle on the solution of that if we don't know F? Well, it turns out you can do something. So let's assume that this in the upper part here is the distribution of resistances. And let's just say it's more or less normal. We don't actually have to assume that. But just for illustration, here's the normal distribution of resistances. And these are now what's going to happen. Down here will be the trace. We're going to trace out the adoption curve based on the learning model. Okay? Ready to go? Okay. Where did that come from? Well, this is the first data point. In period 1, that many people, this is a proportion here, this proportion of the population adopted by the end of period 1. Think of farmers, just to root our ideas. And these are what in the sociology literature are called innovators. The people who generated this didn't have to see any information. They simply were receptive to new ideas, and they went out and they planted the corn, and that's what got the whole process started. Now, this is very well accepted in the sociology literature that there are certain kinds of people like that. Very good. Now what's happened? Well, these people here who adopted, now what's going on there? Well, they're generating information between period 1 and period 2. So they plant the corn, and then the next group of people is going to see what happened. So this is the what happened part. Okay, and after that, well, where did those people come from? Well, after a certain number of people saw the evidence from these people, they jumped on the bandwagon, yes? That's those people there. Okay, and now there are now more people have adopted at the end of period 2. Okay, now let's take it again. But of course, all these people are generating still more information. So now the information is growing quite rapidly, actually. That's why this is, yeah, see, the resistance level are being overcome by the size of these boxes. And, you know, as we get more and more people, there's more and more information. We get a sort of a bigger and bigger jump along the x-axis here. Well, we're getting 2 jumps, actually. We're getting bigger jumps along the x-axis. And meanwhile, we're going up the left side of the distribution, and that doesn't require a normal distribution. All it means is that we're just starting off with anything that's like a unimodal distribution. And so we're actually getting massive increases here in the numbers. It's wider and it's higher. And we keep doing that. We keep doing that. And that's the adoption curve. And you can show mathematically that one of the peculiarities of this curve is that in this area right here, you get super exponential rates of growth. It's actually faster than exponential. And none of the other models in the literature predict this. And that is independent of the particular distribution. So you can play around with this, differentiating that equation or fooling around. You'll be able to show you get faster than exponential growth with a very general classes of F distributions. Okay, I promised I wouldn't bore you with too much mathematics. Here's the actual curve. This is, I think, not bad. At any rate, this learning model can be used to study a great many innovations. I'm now going to take you to the next one, which is your favorite, corporate director awarding themselves stock options. How old a practice is this? 1980s? 70s? Try 1930s. The use of stock options by some corporations as an incentive plan goes back as early as the 1930s, possibly earlier, but we know of data that take us back that far. So already I found this very surprising. Excuse me. And here is the adoption curve. Now, again, we see some very, very curious things here. Starting in the 30s, and by the way, this is large U.S. corporations. I'm only taking the 100 largest U.S. corporations, okay, so just the big guys. This is already very curious here. And it gets curiouser and curiouser once you disaggregate the data, which I won't have time to do here. But this is very slow. I mean, if this is a good idea, here it's taken nearly 20 years to even get to a 5% penetration level. I mean, this is really quite amazing, and that's why you never thought that it went back to the 1930s. It was done, but it wasn't done by many people. Then, or by many firms, then came a big jump, and this you can show actually was probably jump-started by a change in tax treatment in the US of options versus cash or wage income. But then that advantage disappeared in subsequent legislation, so that somewhere around in here they were once again equivalent. So actually, we have to pull that apart and look at the various components in it. But actually, I mean, it's got a jump start, but it's still taking quite a long time. These are a long span of years here. It still only reached 60, 65% by 1970. And then there's this kind of erratic growth in more recent years. How do we explain any of this? Is this, let me just say, do I think that this is clearly a good innovation for society? Actually, the data shows that there is some benefit from options. However, I think it's also true that this is still a contested point in the financial literature, so I advertise right now that this is still a little bit unsettled. Why is this an interesting case? Well, I think it's a very important case. It's a contemporary case. It's an example of a social innovation that is said to have benefits. It organizes incentives in firms in a way that makes those firms more profitable. And that's obviously of a great importance if it is in fact working. Now, there's a very simple way that you can argue that it is, you can observe, yes? You can observe who adopted, and then you can check the adopting firm's stock value relative to the stock value of the non-adopters. So you're going to wash out the changes in the market, and you're going to look at those subset of firms at a given point in time who adopted. How well did they do in subsequent periods in terms of stock market changes relative to firms that did not adopt? Okay, so this would be the relative advantage, and this is very easily available and observable data. What effect should that have? Well, if we see high stock market values or extra returns to these prior adopters, that should lead, in this theory, to a higher subsequent rate of new adoptions, correct? And actually, one would suspect that if this is correct, the effect should be especially strong among firms in the same industry. So I will pay attention as a financial firm to what other financial firms are doing, or as a chemical manufacturing firm to what other chemical manufacturers are doing. And in fact, this is exactly what you see in the data. So I'm going to, because I don't want to dwell on this too long, I want to get to my final case. But my point is going to be that this paper, where you can read all the details, it's in the list of references, actually leads to the following darn good fit. A learning model with this learning from other firms, looking at how they did, gives this sort of a fit to that rather strange looking curve. So the dotted line is the fit, using a normal distribution for the assumed distribution of resistances. This is, massively not a logistic model. So far, so good. Let's move on to our third case. This is one that is of particular interest, again, in the developing world, where people are adopting something more or less often at the village level. And therefore, the social network that reigns locally could be influencing the rate of adoption. So now we turn to this third set of cases that work like that. Agents are embedded in a social network, and let's suppose they obtain information from their neighbors. Let's say the probability of adopting depends on how many neighbors have already adopted, because that's a proxy for the information. Those neighbors have adopted. They're providing information from their actual personal experience to people in their social network. Okay? So it works just like the previous model, except now we're saying, suppose we knew the network relations. Then we would be able to track how the diffusion is a function of the topology of that network. And we're going to use the theory of stochastic processes to make those inferences. I'm not going to get into the weeds here with stochastic processes. For those of you who know anything about this, this is actually a variant of what are called Ising models in statistical mechanics. It's a very heavily studied subject in physics. Here we adapt these theories, which are quite elegant, to the social situation. Just to give you an idea, here's a little set of villages. People are linked, are little clusters, and these clusters are, everybody's linked with everybody else, but in addition, people are linked, but more tenuously, to people outside their village. Okay? And now we're imagining some kind of an innovation comes along, and let's say that everybody's heard about the innovation. This isn't about discovery, by the way. Need to emphasize that this is much more like hybrid corn, family planning, everybody's heard about it. That's not the issue here. The issue is who's going to get started, who's going to actually act on the knowledge that everybody has, and then that will induce other people to jump on. So let's say this is an innovator right here. So what's the next step? Well, maybe because this one communicated good information to this person here, this person, let's say, adopted. And then, and so forth. By the way, I hope you noticed something funny that I just did. See that guy there? The next slide, gone. One of the well-known features in situations like this is disadoption. This is not a one-way street. You can definitely get people, let us say, who try the thing and maybe they just had bad luck. Maybe it was, going back to the farmer example, a bad year, crop failed, they say the heck with it, it doesn't work. So you can definitely get disadoption. And so this model goes on, and this is very related to these models in statistical mechanics, studying them. Let's come to the third case I want to talk about, the diffusion of contraception, which is a very heavily studied subject by demographers. And there's a long, long literature on this going back at least 50 years. And there are really two competing, how should we say, theories that about what's going on and why it is that some areas, regions, villages take much longer to adopt than others, even though information is available to everybody all at the same time. As in family planning clinics, free contraceptives, everything's available all at the same time, yet across a certain region you'll see massively different rates at which different villages take up the practice. Okay, so how do you explain this? And I'm going to here cite one of my favorite papers in this area by Kohler, Bierman, and Watkins, prominent demographers who study this question. And what they managed to do is at least advance an argument as to why both social learning and social norms are important, and how we can somewhat disentangle the two, which is a really tricky question. So, social learning story. Women adopt when they have positive information from others whom they network with that contraception has it's okay for their health, and so forth. Social norms, early adopters are sanctioned. They may be shunned. Why? Because it goes against established norms in the community of the woman's role. It may go against religious norms as well, so these norms may be very, very strong, and people may be punished, as it were, for undertaking the innovation. It's very difficult to see the punishment at work, very difficult to do that, but there's a way of sort of teasing out the two possible the differences in these two results. So here's what Kohler, Bierman, and Watkins propose. They say, well, suppose we knew the network, and we'll just look at network structure, and now let's look at the density. We'll compute, say, here's a target individual, and this individual knows 4 people, and this person might be an adopter, but at the moment we're interested in the following point. None of these people in this person's network are themselves connected. Here, some of them are connected. There's a triad here. Hypothesis of Bierman and company is that that's going to make a difference. So here are, in a larger setting, the 2 different examples I gave. So here are the clusters. Here are the density of every network as a half, because every vertex has 4 neighbors. And of the 4 neighbors, 3 are connected with each other. So that's 3 out of 6 possible links. So the density is a half. Over here, I know this one, I know that one, I know that one, I know that one, but none of those people know each other. Density is 0. Okay, so those are very different in the Kohler et al. Theory, and their hypothesis is simply this. Locally dense networks are more effective at enforcing social norms, but provide no additional information. Now, that's a hypothesis. That gets the model going. And they find that indeed there is strong evidence for this in the data. It leads to the prediction that local density, initially the density or high density will retard diffusion, but later on speed it up, because norms work in 2 ways. First, they operate to push down and retard the growth of the innovation. It's going against the established norm. But now suppose you reach a later stage where almost everybody's adopted. Then the new norm is that you use contraception. And so actually now you can get a flip in which, in the later stages, strongly normative communities may actually go to completion of the process faster than the other communities. So it's a two-edged sword and rather interesting in its implications. And this is what, using Kenya data, they show is that density matters very much. I'll just sort of roughly sketch the curves that they do. The probability of adopting when the density here is low is more flat. It's a more flat response curve. Whereas when density is high and norms are strong, you have this much more bowed kind of response curve. And this has the following effect. When you trace out the actual diffusion of an innovation, actually I'm doing this on those graphs that I showed you earlier, when you have low norms and they're just learning from each other, you get an adoption curve that looks like this being the proportion of adopters. When norms are strong, you have trouble getting started, more trouble getting started. It's slower, but then, and actually you can show that out here, the norm-based communities actually have a higher rate of acceptance at the end of the day. By the way, this illustrates something that I glossed over in the previous studies. Are these S-shaped curves? Well, not exactly. They're stochastic. There's a very strong stochastic random component to these adoption curves when you look at data in small groups like these villages. Let me conclude by suggesting, what does this have to do? What do we learn from this? And does it have any implication for policy? It does have strong implications for policy. And a variety of things have been tried, and some have worked, and some have not worked very well. So I'm going to mention at least 4 policy types of interventions. How do we make the process faster? Yes, if we got a good idea and we want to make it spread faster, what's the right way to do it? Okay, so answer number 1. Disseminate the information about the benefits. Now, this is actually what was done in quite a few of the cases I've been talking about. Local agricultural agents did this in the United States for hybrid corn. They said, here are the benefits of planting hybrid corn to the farmers in the area. In developing countries, there are family planning clinics that play this role. Okay, the information is out there, it's constantly touted, it's publicly available. Nevertheless, we've already seen that in these 2 cases, actually, adoption can be quite erratic and can take quite a long time. So it isn't enough to just disseminate information. People, I would assert, need to learn from observing other people doing it. That's what they have confidence in. Second, provide subsidies. Well, this is the obvious thing that any economist would come up with, right? And actually, in some cases it works, and in quite a few cases it does not work very well. Actually, in the case of stock options, it happened by chance. There simply was a change in the tax law that happened to benefit options because it changed the capital gains rate. But that did jumpstart the process for sure. However, you can provide subsidies for adopting contraception. You can do all kinds of things in the field like this, and actually it's been shown that this has very little effect. Here's one that is very much in the air currently, and I want to raise a cautionary flag about. Provide positive information to opinion leaders. You're going to go to the village imam, you're going to go to the heavily networked individual or the richest individual or some other person in this village situation that has influence, yes? And you're going to explain that if they would please talk up the idea, then it will spread in the community. Now, the latest incarnation of this is an attempt to spread the word about microfinance amongst communities in India. Okay, microfinance, I suppose you know, is there are certain organizations that provide credit to very poor people. Small amounts of credit who ordinarily would not have access to any credit. So these are not banks. They're organizations that, because of pooling that goes on, they can get small loans out to many, many people in a village. But small loans. That's microfinance in a nutshell. And Banerjee et al., Jackson and others have a paper in Science explaining how they ran experiments in India showing how if you get a centrally placed person in the network in a village, then by 6 months later and a year later, more people will have heard about it. Now here's the catch. First of all, this idea has been tried, this is a very old idea, and in fact, there have been a number of prominent sociologists, once again the sociologists have got there. James Coleman, Katz and Menzel back in the 1950s, ran a very similar study of doctors and whether the influential doctors were the ones that spread the news about new drugs. And in fact, there's a book about this and their findings. And what they found was that if the medical practice was fairly clear-cut, the benefits were more or less immediately obvious, then the centrally located doctors would indeed spread the word and people would listen to them. But in cases where the new drug or practice was seen as highly risky and uncertain, then it was exactly the opposite. And it was the peripheral doctors who actually were more active in promoting the innovation. Now, what's the logic of this? Well, centrally placed opinion leaders have a lot to lose. I mean, it's a double-edged sword, right? I mean, of course they're influential, but precisely because they're influential, they want to jealously guard their position, and therefore they're very reluctant, perhaps, to spread ideas about innovations that aren't tried and true. Okay, so they may be very conservative. Now, here's a wonderful example of this. Dueling. Well, this is, I think, by anybody's estimate, a bad idea, yes, but norms existed in Europe not so long ago in which if you perceived that somebody had slighted you or insulted you, you were bound to challenge them, and the challenged person, to avoid losing face, would take up the challenge, and there were many deaths. Okay, this was usually done with pistols, and especially, it lasted for a long time in France, longer than in Britain or the US actually, until the end of the 19th century. There have been whole books written about this. One of the interesting points about dueling is there were lots of it was widely recognized that this was cracked. I mean, that if you could just stop the norm, everybody would be better off. Nobody really wanted to be in this bad equilibrium, but once you're in it, you would lose tremendous face if you didn't play your part. All right, so attempts to outlaw it definitely failed. There were at least half a dozen different laws against it in France through the 19th century. None of them were carried out. Problem. Well, of course, the real problem here is that the leading social and political figures in the community were the very ones that were most implicated. They were the ones typically actually carrying out these challenges and duels. And so the idea that you would spread the idea of stopping the norms through these people is completely wrong-headed. These were the people who had the most to lose and would be the most difficult to persuade. So this is my cautionary note about this opinion leader's approach to intervention. Then finally, a fascinating example of policy intervention is the idea that you shift, because it's an equilibrium, what you have to do is shift the expectations of a large number of interacting people. Maybe it's not large, but they're interacting, say, at a local level. So for example, you target a group within a village. You don't try all villages. You go to a specific number of villages and you get a sizable group of people to all agree to shift in a coordinated fashion. And this shifts the equilibrium at that village, and then you've gotten some leverage from that. So this has been tried in a number of areas. A famous case of ending foot binding in China was through work of so-called foot emancipation societies, which operated by forming groups in which certain families would contract to marry their sons only to daughters who did not have bound feet. Now, the logic of foot binding, by the way, was precisely marriageability. So you bound your daughter's feet, and this is a very ugly practice. See that on the right there? This is not a nice thing to do to your daughter, but that's an example of bound feet. Families would bind their daughter's feet, sorry, I'm trying to get back there, so that they would be marriageable, and that was the norm. Men expected to have, of a certain social class, expected to have marry a girl that has feet were bound. So the only way to get out of the equilibrium and still get your daughters married was to have a sort of a concerted effort in which a group of families would contract to, shift the equilibrium. Now that's been tried as a strategy for reducing forms of female circumcision in sub-Saharan Africa currently. Again, the idea is targeted at a group to shift expectations within an intermarrying group. And for those of you who want to read about that, it's Jerry Mackey and co-authors, which are listed in the references.
The Chinese, was this before the communists took over or during communist times?
This was all in, this is before the communists. This occurred around 1900.
So it was not centralized?
No, not at all. This is in traditional Chinese society. To conclude, diffusion is complicated. It's driven by both sociological and economic factors. I would say that inertia, learning, social norms, have to be taken into account and play a greater or lesser role depending on the situation. I'm arguing that learning is especially relevant when benefits are uncertain, and you therefore rely on the experience of others to estimate how good an idea this is. So there you have it. A combination of sociology, economics, and mathematics can help us understand this extremely important problem. I think it's surprisingly understudied in economics. There should be whole courses on innovation and innovation diffusion. It's that important, but nowhere are there such courses to date. So thank you very much for your attention.
That was a real stimulating lecture that touched on most of LSE's departments, actually. I managed to count references to economics, finance, anthropology, sociology, international development, social policy, psychology, statistics, of course, media and communications, history, economic history, and gender studies. And it's all mathematics. Or at least mathematics tells us something about these subjects in this context. So thank you very much, Peyton, for a wonderful lecture. We've got plenty of time for questions. I think we have a microphone for questions. It's probably good that we use that so that they can be heard on the recording. So, does anybody have any questions or any comments they want to make? Yes, down here with the blue shirt.
Thank you. I think the mic is not on.
Yeah, it is.
So I think what I'm not a mathematician, but I think what you're saying is that there's a pattern of adoption which is common between innovations. And you talked briefly about disadoption. I was wondering if you can spot a fad, and by that I mean rapid adoption followed by rapid disadoption, and whether you can predict whether an adoption is going to be a fad or is going to stay with us for the long term.
Good. First of all, I don't think that these processes are predictable. Fads, which I didn't really cover here, somewhat deliberately because I wanted to emphasize the importance, really, of all of this to economic growth. Fads come and go, and therefore I'm not sure we would argue, or I'd like to argue, that they are really important phenomena. Of course, we want to understand how they work from a social point of view. I think you're right, they do fall into this general category. And actually, there are models there where you're not, they're so-called bandwagon models. So the more that people are just doing something, that exerts a kind of an attraction effect and increases the probability that the next person will jump on. It's merely numbers of people that is leading adoption. And of course, once that starts to break for some reason, then you can get disadoption for in exactly the same way, and it goes into reverse. So to model that, you would use this idea of stochastic processes that I talked about toward the end.
Okay, there's a question, gentleman at the back with the red scarf.
Thank you very much. I'm Haider Rida from Bain & Company. One of the organizations that has been most successful at spreading or diffusing innovations recently in the past years, unfortunately, was ISIS. Being able to spread an ideology that got children from Manchester to go to Syria, people from Uzbekistan, people from all over the world. People going there thinking that they're gonna, 15-year-olds from Manchester going there thinking that they're gonna be a kind of Robin Hood, while actually they're joining an organization that is enslaving, killing, at a scale that hasn't been seen for hundreds of years. So I want to hear your view on, based on this astonishing research, what would you suggest is a way that this could be used to stop that diffusion of ISIS propaganda, and on the other hand, build a counter-narrative against that creed, to show people what they're actually joining, and to stop the trickling of people going there from all kinds of places in the world. Thank you.
Well, that's a tricky one. Of course, first of all, this does get at the question of observability of results. So joining ISIS and looking at the consequences of joining ISIS further along is probably a very uncertain process for young people. They don't actually see the implications of what they're doing, and this is because the observability factor isn't there. So that would be a perhaps overly simplistic, but one vital point that makes that case not really fit into the framework that I've talked about here. And it leads me to hesitate to suggest a kind of policy intervention that would work. Certainly recruitment by influential and persuasive people there, in that case, will matter. And I argued a little earlier that in other cases, influential people will be the last ones who want to put their reputation at stake to advocate an idea, even though it might turn out to be a good idea. So I think this is kind of flipping the entire sort of what is the role of leadership? It's flipping that on its head from what I was saying. But more importantly, the observability aspect is simply gone in this case, in my opinion, and people don't receive informational feedback. I suppose, if you wish, that suggests a possibility. How could one increase general knowledge of the consequences of joining ISIS? Maybe that is what would have to be more widely known, and that might have some positive effect.
Very good question. I can add international relations to my list now. There's a question here.
I have two questions. The first one is, we have so many technology innovations every day, and is it possible that we study one technology at the early age and to see if they fit in the categories of diffusion, or they have some characteristic that make them inherently not be able to be diffused to a certain level of penetration rate? And the second question I have is, in terms of policy interventions, I forgot my second question.
We'll come back to you.
Yes.
Well,
just one.
can you give an example of what you're thinking of?
The first one's, for example, like carbon capture and storage. So someone says promising in terms of combating climate change. Someone says just bridging technology. It's going to be given up in few decades once there's like fusion reactors is going to be on board.
Okay, so those would be examples of technologies, again, whose cost, in the list of propellants of innovation, one of them is improvement. Improvement in the product, refinement of the product, together with declining cost. So I would argue that in those kinds of cases, indeed, one may have to wait until carbon capture is more proven as a cost-effective measure. So that may propel it forward, okay? But that may be a waiting game. And there are a lot of technologies that work this way. I mentioned the cell phone example. Cell phones were not a great idea in 1972. They looked terrible. They were extremely expensive and clunky. So it took constant refinement to make them accepted. Now, the refinement might not have happened except for some very innovative firms, actually Nokia in Finland, which was where the data come from, undoubtedly was one of the key innovators in the sense that they refined the product and made it more widely accessible. So private firms will often have an incentive to do this.
Is that something of observability you just mentioned in your speech? You need to wait some observable factors to appear before you can judge what kind of model is going to fill into.
Yes. Yeah.
Okay. Yeah, my second question is, you mentioned like subsidies doesn't work in some cases. So could you give some examples where subsidy is not really effective?
Oh, actually there are, I mean, just one that comes to mind immediately is in the female circumcision debate and attempts to intervene, one of the standard interventions has been to pay there's a group of women that perform the operations. They're specialists. They're called cutters. A widespread attempt over quite a few years was made to pay the cutters not to cut. Disincentivize the cutters. Therefore, they would still be able to have a living. Yes, they would be able to earn a living. And at the same time, they would not be performing the act. Well, it turns out that this just didn't work. I guess the explanation for it is that, well, maybe the incentives weren't large enough, but more importantly, these social norms are extraordinarily strong. And I think often financial incentives just don't substitute or not adequate substitutes for the issues of marriageability of your daughter and so forth. That requires a different kind of intervention.
Okay, behind you.
So it seems clear to me that in the 1950s and in the 20th century, if you were a farmer in Iowa and you heard about this new corn technology, you might want to check with your fellow farmers in your state or in your province. However, nowadays, probably the farmer would just go online and just see how good this innovation is. What I mean by this is, do you think that this dependence on adoption observability will shift or will have less importance now that we have more information available to all of us? And a follow-up, do you think that maybe instead of trying to make these villages aware that other villages are doing these things that are good and that might benefit them, it would be better just to try to give the internet to these villages and just to provide them more information? Obviously, it's probably a bit harsh, but I mean, just question.
Very nice point. I guess I'm a little skeptical that this is going to have much of an impact. The information was in the 1920s, 30s, 40s, widely available in a sense that the internet wouldn't much improve upon, because there was something called an agricultural extension agent in each community in, say, Iowa. And that agent was a kind of public resource who would provide all the information that anybody would want about what people in the region were doing, about past experience in other states, and still it didn't have nearly as much effect as Farmer Jones going down to his next door neighbor and saying, well, how did it work out? So Is this going to be overcome by our modern internet society? Perhaps, but I think I would be skeptical, actually.
Do you think there are any differences in the shape of the relations or the functions from like a period between like 1950s and 2000s and 2000s and onwards?
Well, you'd have to. I don't know that anybody's tried to look at that, so that's a nice research question. Let me just say one thing, though, that's really hard in studying this problem, is actually data is not that easily available. And one of the difficulties here is that you can think of lots of technologies, but the technologies will often be touted by a particular firm, and so everything depends on their particular marketing strategy. So what you need to look at to test some of these theories that I've been discussing are there things out there that are not sort of proprietary, number one. They're just out there as ideas, and they have a dispersed aspect. That is to say, people are learning about them in some sort of localized fashion. And you're suggesting, well, maybe there are fewer examples of that, localization nowadays, because of access to general internet public information. That's a very interesting point, and I don't know what data set you'd test it against, but I think it's worth exploring.
To think about something just out of the blue, for example, the Arab Spring, it's very hard to think that that it's very hard to think that the Arab Spring would have succeeded if it wasn't through social media, for example. So it seems that just talking from villages to villages, this would not have had the rate of expansion it really had.
Okay, that's entirely possible.
Yeah, I suppose you're suggesting that the existence of the internet affects a reconfiguration of the network that underlies
I'm suggesting that instead, so we are substituting in some way the weight we put on the information provided by our fellow mates, or just like the people in our circles, in the networks, the closest nodes, with some sort of external information given by the internet. Each person might just qualify this information, maybe it's a pondered average, I don't know.
So there's almost two separate networks overlaying each other. Yeah.
Yes, that might be an idea.
Interesting. Bernard?
Different? Yeah. So I have, in a sense, so here's a question that relates to the, it might be the sheer network effect that propels something, for example, not the quality of the product, say, for example, there's this, for instance, they had a standard on video cassettes, Betamax and VHS, and VHS, which become much more widespread, had probably a better diffusion rate than Beta, despite the fact that it was possibly technologically inferior. So is that something you would say, that, the diffusion rate is more important than the quality of the product in some circumstances?
Well, that's a particular feature of the first example I discussed, which was the increasing returns type of technology. So when you have that feature, then indeed whatever gets an early start is going to seize the lion's share of the adherence by the end of the day, even though it may turn out ex post to be inferior. Now, one of the classic examples of that is the paper by Paul David on the different layouts of the typewriter keyboard. So QWERTY, which is, at least in English-speaking countries, the standard layout, or the left upper row, was designed specifically by, I think it was Remington typewriters and somebody working for Remington. There was another competing technology. It was designed by a famous motion study guy who put lights on typists' fingers and took movies of how much the fingers moved in typing a test set of manuscripts, and laid out the keyboard in a different way called Dvorak. And this layout supposedly gave the typist inherently 20 or 30% faster rate. But the trouble was that once you got a standard, as you've indicated, and once QWERTY became a standard, then Dvorak, even though subsequently it was shown it was better, had then, had fallen behind. And that's because of this increasing returns feature of the technology, which is not true of all technologies. It's true of some of them.
And the second question, I mean, you could, for instance, Amazon started with zero profits for a long time because they were more focused on growth than on profits, because they wanted to make the curve grow as fast as possible. Is that something you can quantify, how much you should spend into expansion rather than profitability? Maybe it's not the same story, but it reminds me, of adoption rate.
There is some literature on this, but once again, this is a kind of an increasing returns or monopoly type of story. And another way in which this is, some marketing people, including marketing academics in business schools, write about this very question. So I've kind of sidestepped that one. And in fact, I chose my example specifically because to do case studies on, so I chose them so that the increasing returns part was perhaps not so important, right? Because that tends to confound the entire analysis.
Questions? Yes, right at the back.
Thanks. Yeah, another question. Have you seen any companies that are better at this than others, and what could they do? So businesses could, for example, focus on creating recommenders or people that recommend them to other potential clients, which is the NPS concept. Is there anything else as a so what for businesses here? Thank you.
So there are a number of strategies. One of them that's related to this coordinated, this idea of coordinated change is what's called viral marketing. Viral marketing is a procedure in which you specifically target or even give away your good for free to a certain number of people who interact with each other. And so the idea is that from this neighborhood, other people then hear enough about it, so they adopt, and then they become spreaders. And so this, as I say, this goes by the name of viral marketing. It's very like what I was talking about toward the end of making this topology work for you, so that if you target enough of these little villages, then in each village it will go on to spread by itself. That's the idea.
Any further questions? No? In that case, let's thank Peyton Young again for a very stimulating talk.